In the past, when explorers traveled across the world, they often got lost. Sailors used the stars to guide them. Early sailors discovered the magnetic quality of the Earth when they found that each time they suspended a lodestone rock from a rope, it would spin until it stopped in a certain position. The position in which the lodestone was always the same. Perhaps they did not have the scientific knowledge to understand the properties of magnets and magnetism, but they had discovered how to make a directional compass. They had also discovered the position of magnetic north. This must have revolutionized the way in which sailors traveled so many centuries ago. There is a difference between true and magnetic north. True north is situated at the North Pole. So when one uses a directional compass to determine the position of north, one needs to make a small calculation. The calculation depends upon the position of the directional compass. The angle between true and magnetic north will vary at different places on Earth. This angle is called the angle of declination. In South Africa, the angle of declination is approximately 23 degrees west. Each magnet has a north pole and a south pole. This is called the polarity of magnets. When magnets are placed near to each other, the south pole of the magnet is attracted to the north pole of another magnet. We say that opposite poles attract each other, but similar poles repel each other. This shows the magnetic field of a bar magnet. The magnetic field is the area in which a magnetic material will be attracted towards the magnet. Let us conduct a simple investigation about magnets. We are asking the question, are all materials attracted towards a magnet? Therefore, the aim for this investigation is to determine if all materials are attracted towards a magnet. We can formulate a hypothesis. What do you predict will happen? Do you predict that all materials are attracted towards a magnet? Or do you predict that only some materials will be attracted towards a magnet? To conduct the investigation, use a brass 10-cent coin, piece of paper, seal paper clip, plastic bread bag fastener, and wooden pencil shavings. Place them near the magnet. What do we observe in this investigation? We see that the brass coin and seal paper clip are attracted towards the magnet. The piece of paper, plastic bread tie and wooden pencil shavings are not attracted towards the magnet. What conclusion can we draw? We can decide that some materials are attracted towards a magnet whilst other materials are not attracted towards a magnet. We say that materials that are attracted towards a magnet are magnetic materials. Investigation 2. Can materials be separated using magnetism? Our aim for this investigation is to determine if materials can be separated using magnetism. What do you predict will happen? Do you predict that materials can be separated using magnetism? Or do you predict that materials cannot be separated using magnetism? To complete the investigation, you need to collect a small amount of sulfur and iron filings. Sulfur is created when volcanoes erupt. Iron filings are small pieces of the metal iron. Make a mixture of the sulfur and iron filings. Hold a bar magnet above the mixture. Observe what happens. You should see that the iron filings are attracted towards the magnet. Therefore, the mixture of sulfur and iron filings has been separated. We can decide that materials can be separated using magnetism. Let us summarize what we have learned. The needle used in a directional compass is magnetic. The needle of a directional compass points to magnetic north. Magnets have a north pole and south pole. This is known as the polarity of magnets. Opposite poles attract each other. Similar poles repel each other. The magnetic field is the area in which a magnetic material may be attracted towards a magnet. Some materials are magnetic because they are attracted towards a magnet. Some materials are not magnetic because they are not attracted towards a magnet. Materials may be separated using magnetism.
Ha 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 ha.